Hello, everybody, and welcome back. We're continuing our notes on Chapter 9 with atmosphere and severe storms. And this diagram is towards the back of your notes. It's going to deal with air masses, that is, large, maybe thousands of kilometers wide masses of air, and also fronts as well. And so we're going to look at 4 different air masses that affect North America. And then at the bottom right here, we're going to discuss what fronts are and kind of label them and give them some names. Okay, but for right now, look towards the top. And by the way, you're going to want a red and a blue colored pencil because they're going to indicate different temperatures right here. So North America is kind of interesting in that towards the north part of it, it gets pretty wide. That is, there's a lot of land towards the north. Yeah, there's a little bit of water in here, but for the most part, between Alaska and Greenland and this northeast part of Canada right here, there's a lot of land. As you go more south, you'll know you'll notice that it gets more narrow, and towards the bottom, it kind of gets tighter and tighter, and it becomes very skinny down towards the bottom of Central America. That really comes into play when determining what kind of air masses come in to our continent. So let me just go ahead and start labeling and start telling you about the 4 different kinds. First of all, I need to give you 2 different sets of terms. All right, with regards to temperature, or let's see, with regards to humidity. Oops, oh goodness, I am using a really, really thick pen right there. Sorry, there we go. With regards to humidity, we have 2 different adjectives, you might say, and with regards to temperature, we have 2 as well. All right. With regards to humidity, that is either humid or not humid, we have 2 terms. One of which is called maritime, and that's going to be a lowercase m. Okay, M-A-R-I-T-I-M-E. Whoops. M-A-R-I-T-I-M-E, and that means coming off of the ocean. It's like the word marine, not the soldier marine, but marine as in dealing with the ocean. All right, now maritime mariner, somebody who's a sailor. Actually, the soldier marines come from that as well because they're a division of the Navy. So anything with M-A-R-I in it deals with the ocean. Versus continental. C-O-N-T-I-N-E-N-T-A-L. All right, and that is any air mass that originates over the continent is going to have the opposite in terms of humidity. That is, if it originates over the ocean, it's going to be very humid and full of water vapor. If it originates over a continent or comes from over a continent, it's most likely going to be pretty dry. All right, so both of these terms right here are kind of opposites in terms of humidity. Humid, dry. With regards to temperature, we have 2 as well, and that is tropical, and that's a capital T, T-R-O-P-I-C-A-L, A-L. And as you can imagine, anything coming from the tropics is going to be warmer versus P for polar. And that means anything originating from the poles is going to be colder. So we have 4 possibilities right here. We have warm and humid, and warm and dry. Then we also have cold and humid, and then cold and dry. So these 4 different air masses are going to affect our nation, but our continent actually. I'm going to go ahead and start with one that comes down from Canada and comes off the land. So it comes from the north and from the land. So I'm going to draw a big kind of block arrow right here. Like that. Okay. And what I'm going to do is I'm going to leave it an open arrow. Don't shade that in. Now I'm going to label that continental polar, CP right there. And by the way, I'm not sure if you can really tell, the temperature adjectives are capital letters. The humidity adjectives are lowercase letters, even though, as you can see here, the humidity comes first. So it's lowercase c, capital P, continental polar. Continental means it's going to be dry, and polar means it's going to be cold. All right. Well, let's contrast that from humid and cold. So let's say an air mass comes in into the United States, not from Canada, but from off of the northern Pacific. All right. Well, that's going to be cold, definitely. But coming off of the Pacific, we say that it's maritime, right? Maritime means originating over a marine environment like the ocean right there. So it's going to be full of water vapor. So maritime means very humid. Polar means cold. And so this is going to be humid and cold. But the way that I'm going to differentiate this is that I'm going to fill it in with that color. I'm going to fill it in with blue. All right, so I'm going to shade this in right there like that. I'm not doing a very good job. You're probably doing a better job than me. All right, but shade that in because that indicates that it's full of water vapor. Full of water vapor, all right? There's also another one that comes off of kind of the North Atlantic, but it doesn't get very far. As you can see, these arrows are kind of going from left to right, right? So it kind of grazes us sometimes. Oop, I don't want to do that. I want to change my transparency here. It kind of grazes us sometimes, and that's a terrible, terrible arrow. Try it one more time. If you've ever heard of nor'easters, all right, it's a little better arrow like that. These are storms that kind of are affected by cold and humid air that comes off the North Atlantic. So I'm going to take that and I'm going to label that also maritime polar, but that doesn't affect us too much because as you can see, the air is moving towards the right from the left. All right, and we'll our discussion on wind patterns should kind of inform you on that, but these don't affect us very much because it just sort of graze our northeast. And honestly, these don't affect most of the continent very much either. Why is that? Why do these air masses coming from the North Pacific not move all the way across our nation? Well, they do actually eventually, but what prevents them from totally moving across? Well, we've got the Rocky Mountains. Darn it, I still don't want to do that. Make my thing skinnier. There we go. We got the Rocky Mountains right here. All right, big chain of mountains, and so this air mass doesn't affect us too terribly much. It certainly affects our Pacific Northwest. You probably know that Seattle and Portland, cities in our Pacific Northwest, get a lot of rain and tend to be very humid. All right, but this doesn't move too far into the continent because of the Rockies. The really big player from the north is this continental polar air mass, cold and dry coming down from Canada. And honestly, this is what provides the cold that creates the blizzards that we, well, sometimes look forward to during the winter. All right. Like I said, these here create what we call nor'easters sometimes, but again, since everything's moving from the west to the east, this just sort of grazes us a little bit and doesn't really affect us. So once again, continental polar from the north is the big player right here. All right. So from the south, what do we have? Well, from the south, we've got a lot of water. All right, the continent gets skinnier and skinnier down in here. All right, so we're going to draw one big air mass that comes from the south. And of course, we're going to change colors because coming from the south, coming from the tropics, it's going to be warmer. So there's a big air mass coming off. That's not a very arrow again either, but that's all right. Coming kind of from our southeast. All right, and this is going to be, well, where does it originate from? Well, you got the Gulf of Mexico right here. There's a lot of water down here. So we're going to say that it's maritime, right? Comes from marine environment, comes from the ocean. But instead of polar, it's going to be tropical, right? Maritime tropical. And what I'm going to do, once again, is I'm going to shade this in with a color because shading in the arrow is going to indicate that it's full of water vapor. All right, so this is a very humid air mass. My shading isn't very lovely right there, but you get the idea. All right, maritime tropical. That's a big player that comes in from our southeast. All right, but there's some other ones. There's also a maritime tropical air mass that comes in from our southwest as well. This is sometimes called the Pineapple Express because it comes from Hawaii. All right, and so that can really make our that can really affect our American Southwest right here, especially Southern California. But once again, this doesn't get very far into our nation because of the Rockies right here and lots of mountains. So this really just primarily affects our Southwest. All right. By the way, for that reason, the city of San Diego is a very nice city to live in. But that also is Maritime Tropical too. There's one other one that comes in from the south. Now this is from off the water, so it's maritime. This is from off the water, and that's maritime as well. But there's one smaller one that comes in right from Mexico. And that's the fourth possibility that we have, and that is Continental Tropical. All right? I'm leaving that open because it's a dry air mass. It's not full of water vapor, and it can affect portions of our Southwest. You'll know that states like Arizona and New Mexico and Texas tend to be very dry. All right. Well, that's affected by this continental tropical air mass coming in from the south, right from Mexico, right there. But really, the big ones that affect our continent are this maritime tropical coming in from the southeast, and this continental polar air mass coming in from the north. These are the two that slam into each other right in the very breadbasket of our nation right there, and also are the two main air masses that contribute to what we call Tornado Alley. That is the big air masses swirling together and not wanting to mix and providing the, you might say, the force required to generate all these tornadoes and supercells. Okay, so these are four different kinds of air masses: maritime polar, maritime tropical, continental polar, and continental tropical. These two guys right here are the big ones. Okay, so that's the air masses that affect our nation. Well, what happens when these air masses actually collide? What happens when they actually hit each other? Well, at the bottom right here, we have these weird-looking diagrams. These are going to represent fronts, okay? And what a front is, as you saw in your notes, is an area where, it's actually a military term, it's an area where two armies collide. All right, well, each of these diagrams right here represents sort of a side view. That is, this line that I'm drawing here, these dark lines, represent the ground. And we're looking at the ground from a side view and seeing these different air masses hit each other, all right, and interact. All right, so the first kind of front that we have, and I'm going to write this in red, is a warm front, okay? W-A-R-M. A warm front. Okay, and what happens here is that we have warm air sitting here, and we also have cold air over towards the right. Okay, what happens when warm air comes and moves in on cold air? Well, warm air is less dense, warm air is prone to rise, and so it's going to slide up over that cold air mass. So I'm going to take this and I'm going to sort of outline that right there as if it were. It's not a very good outline. It's one big blob of warm air. And this down here, I'm going to sort of outline as if it were a blob of cold air right there. All right, now I would suggest to you maybe possibly shading it in. I'm going to try to shade it in very lightly. All right, that doesn't look very good at all, does it? And I'll try that as well. That looks terrible too. Well, hopefully I do a better job of shading and get my pen to work right. Okay, but what happens right here? Well, the warm air is rising up over the cold air. Now, what do we say happens when air rises? When air rises, especially warm air, and warm air is more prone to be humid anyway, it cools. And when air cools, it condenses. And so we're going to have, as this warm air rises up, we're going to have it, see it rising up pretty gently, a pretty gentle slope. We're going to have this condensing very progressively into some light rain as it rises up gradually over that wedge of cold air right there. Okay, well, let's contrast. Oh, by the way, there's a symbol for this. All right, and the symbol on a weather map is an indicator of where that warm air is actually contacting the cold air on the ground. So it would be like right here where the warm air is touching the cold air at the ground level. And the symbol looks like this. So we've got a horizontal line, and it has red semicircles on it. I would shade those in like so, okay? But there's semicircles. Oh, that looks kind of like a triangle right there. I don't want to look too much like a triangle. Semicircle. So we see a symbol like that on the map. That indicates that warm air is moving in and overtaking cold air and rising up over it. So let's contrast that now against what we call a cold front. A cold front, C-U-L-L-D, you know how to spell cold. Cold front, it looks like CAD front, doesn't it? C-O-L, let's fix that. C-O, cold front, there we go. A cold front is where just the opposite happens. We've got cold air here, and we've got warm air over on the right, just kind of minding its own business. All right, well, I'm going to outline each of these as well. So we'll outline the cold air. Oops. All right, like so. And we have the warm air sitting here. So this whole chunk right here is warm air. My aim isn't very good there. And so what happens? Well, this cold air is more dense. It actually throws its weight around more. Cold air is moving in and it's pushing underneath the warm air. Remember, warm air is less dense and is prone to rise up. Well, if the cold air is doing the pushing, it's like it's wedging underneath the warm air right there. And so what's the warm air going to do? The warm air is going to be shoved upwards by the cold air. And I'm not sure if you can really tell, but you might say the angle from the warm front is a much shallower angle than this right here. The warm air is boosted up very, very rapidly. And so it's going to cool and condense very quickly, and it's going to form a very tall, towering cloud formation that we call cumulonimbus cloud. All right, well, instead of very light rain, this is going to produce some pretty rapid, violent rain because the warm air is rising up so rapidly. By the way, I'm not going to shade these in anymore, but I recommend that you do, just to kind of help yourself visualize this. But this is going to be all warm air. This is all cold air right here. But along cold fronts is where you have some violent thunderstorms because warm air is being forced up very rapidly. Right here, oops, I meant to do a laser pointer. Right here at ground level is where the cold air is touching the warm air, right? And right there on a map, if you were to look down on it from overhead, you would see a symbol that looks like this. A blue line, usually, and on it, it has blue triangles. All right, and they're usually shaded in right there. I'm trying to fill them in. Okay, but that indicates where cold air is pushing towards warm air. By the way, the direction that the symbol is on, the triangle, indicates the cold air is moving that way. So the cold air is, so here's a line. So here's cold air at the bottom, warm air at the top. The cold air is moving towards the warm air. So imagine taking this and just putting that right there sideways on the ground. All right, two other kinds of fronts. Try to get through these fairly rapidly. Third kind is called a stationary front. Stationary, and I'm not going to write front there just for space purposes. But a stationary front is what happens when warm air and cold air hit each other. All right, so there's going to be warm air on the left right here, and there's going to be cold air on the right, and I am going to outline those. Okay, so there's your cold. And again, this is from the side view now. There's your warm air. Right there. They hit each other, but don't really have enough energy for one to push over or underneath the other one. All right, and so what happens is this. Now I'm going to draw something that hopefully you can figure out what it is. The warm air, now remember this is looking at it from the side. The warm air and cold air are going to start trying to move around each other. So it's like the warm air is going to start to want to move towards us, and the cold air is going to want to start to move away from us, that is, from our point of view. So I'm going to try to draw a three-dimensional arrow right here that indicates kind of coming out towards us. So something like something like that. All right, that means coming towards the viewer right there. And conversely, let's draw an arrow going away from the viewer, like kind of like that. All right, hopefully that makes sense to you. So these two armies, it's like they hit each other and they say, nah, we don't want to fight, we're just going to move around each other. So one moves this way, the other moves that way, they start to move parallel to each other in opposite directions. So they kind of say, well, we'll just go around this way and we'll go around this way and try to get around each other that way. But the reason we call it a stationary front is because it takes a long time for this front line to kind of go away. These two air masses they take their time moving around each other. So a stationary front, what happens here? Well, we know when air cools, it condenses. And so really just where the warm air is touching the cold air, it condenses because it's being cooled by the cold air. And so we have some light precipitation right there. But a stationary front can hang around for a few days and just produce just a couple days of general raininess and not very nice weather. All right, so stationary front looks like this. Usually it's a line, and I'm going to center that a little bit better. It's a line that looks like that. And on one side, you have the red semicircles. Okay, we're going to shade them in. And you probably figured out that on the other side, we've got the blue triangles. My aim isn't very good here. Yeah, not at all. Those are supposed to be blue triangles, sorry. And the red ones are supposed to be semicircles. Okay, so that indicates a stationary front. And that means on one side it's warm air, and the other side is cold air, but they're actually moving around each other in parallel directions. Okay, the last front type is called an occluded front. Occluded. And this is actually a combination of two previous front types. Look right here. On this side, it looks like a cold front, doesn't it? Because here's I'll label them first. Okay, that's cold. This is also cold, and this is warm right here in the middle. Okay, so this whole air mass is warm, and we've got two other air masses right here, cold and cold. All right, now again, I suggest you fill them in. My filling in wasn't very pretty, but if you look here, look closely, you'll see two different fronts together. On the left-hand side, we've got a cold front, right? Cold air is pushing underneath warm air right here, and so that's exactly what we see right here. On this side, on the right-hand side, we see a warm front. That is, warm air is kind of gradually rising up over cold air, which is what we see here. And this is exactly what's happening. What has happened is, and really I probably should have had this diagram over on this side, but cold air is pushing over into warm air, and that same warm air mass is rising up over another different mass of cold air. Okay, so what has happened is these two cold air masses have kind of met underneath the warm air and have taken that warm air and forced it up. So it's rising up over this cold air mass and rising up rapidly over that cold air mass right there. And what occluded means is the warm air has been cut off from the ground. You can think of it as being like excluded, or not included, not touching the ground, right? Occluded means separated from the ground by two cold air masses pinching underneath right there. And so that warm air mass is going to be rising up because of these two cold air masses right here. And on this side, you're going to have some pretty heavy precipitation. And on this side, it's going to be a little bit lighter as well. But an occluded front is always going to result in some sort of precipitation because the warm air is being forced upwards. An occluded front, many times it'll be drawn as purple. I'm going to draw it as red and blue. An occluded front looks similar to a stationary front, except the symbols are all on the same side. All right, so like that. And just to show you that the symbols should be different, I'm going to draw a triangle there and a triangle there, and so forth. Many times, like I said, you'll see that all is one color, But an occluded front, where two cold air masses have pinched underneath the warm air mass, is going to look like this on a map. All right? So there you have it. That's our air masses and our front types. Please make sure you know these for your test, of course. And if you have any questions about these, please make sure you see me, and we'll discuss it further. Thanks for watching, and I'll see you on the next one.